previous videos, we talked about implicit differentiation and finding dy over dx when you have an equation that's expressed in implicit form instead of explicit form. So in this video, we're going to do something similar, but instead of finding dy over dx, we're going to find the derivative of x and y with respect to a third variable t. So for example, if I want to suppose that x and y are differentiable functions of t, I want to find dy over dt when x equals 3 and dx over dt equals 2 for y squared equals 3x squared minus 5x. So I'm going to start off with my equation, y squared equals 3x squared minus 5x, and I'm going to take the derivative with respect to t of both sides. So instead of the derivative with respect to x, we're going to take the derivative with respect to t. And then I'm going to split that up. Like so. Now you may notice that for all three of these derivatives, I now have a variable mismatch. None of them match. So for every single one of these derivatives, I'm going to have to multiply by d whatever variable I'm looking at over dt. So this is going to be the derivative of y squared is 2y times dy over dt. Here I'm going to have 6x times dx over dt, because again, these variables don't match. And here I'm going to have minus 5 times dx over dt. Okay, so from here, I need to look at what the problem is wanting me to find. The problem wants me to find dy over dt, and they've given me x and dx over dt. And you can see that we have an equation that has these pieces in it. We've got the dy over dt that we're looking for right here. We've got the x, we've got the dx over dt, we've got another dx over dt, but we also need to know y, and we don't know that yet. So I'm going to come over to the side on scratch paper, and I'm going to find y when x equals 3. So to do that, I'm going to plug back into the original equation. So y squared is going to be 3 times 3 squared minus 5 times 3, which is going to be 3 times 9 minus 15, or 12. So y squared is 12, and y is going to be plus or minus the square root of 12, which is plus or minus 2 square root of 3. So unless you're told a specific restriction on y, which we aren't in this case, we just know that it's a function of t, we do want to consider the value of dy over dt for both of these values of y. So if we have y equals 2 square root of 3, plugging everything in, I'd have 2 times 2 square root of 3. I'm going to write dy over dt in red just to remind us that's what we're trying to find. That's going to be equal to 6. Our x was 3. So 6 times 3, and our dx over dt was 2, minus 5 times 2, and solve that. So I would have 4 square root of 3 dy over dt equals 36 minus 10, or 4 square root of 3 dy over dt equals 26, and then I will divide by the 4 square root of 3. So I get that dy over dt is equal to, let's see, if we cancel here, I can cancel a 2, so that leaves me 13 over 2 square root of 3, and if I rationalize that, I get 13 square root of 3 over 6. So that's one of my answers. If y is equal to negative 2 square root of 3, then you would do the same thing. That's the only thing that changes. And then if you follow the math down on this, you get that dy over dt is just negative 13 root 3 over 6. So depending on which y you start at, you get a different value of dy over dt. So that's how you solve a really basic related rates problem. There's no word problem attached to this. It's just the rates dx and dy dx over dt and dy over dt are related to each other through the variable t. So we'll do another one of these. Suppose x and y are differentiable functions of t. We want to find dy over dt when x equals 2 and dx over dt equals 1 for y equals x squared plus 3. So I'm going to take the derivative with respect to t of both sides. I'm going to split up the right-hand side. And I'm going to note that I have a variable mismatch in two places, and this one's just a constant, so it'll be 0. So this particular answer is dy over dt. It's just 1 times that. Here we have 2x times dx over dt, and that's going to be plus 0. So I get that dy over dt is equal to 2x dx over dt. And again, we're looking for dy over dt. So in this case, we don't actually need y because there was no y in our answer. So I can just plug it in. So when x equals 2 and dx over dt equals 1, the dy over dt is going to be equal to 2 times 1, which is 4. And that is my answer.